we have one more talk before our break. I'm going to ask Kaon Thana to come up, and he's going to talk about applying platform engineering principles to on-premises network infrastructure. Kaon is from the New York Times, so we're talking about physical infrastructure that exists all the way into printing plants and things like that. So definitely not the cloudy side of platform engineering. Take it away.
Hello, test. There we go. All right. Okay, thanks everybody. My name is Kaon. I'm a network engineer at the New York Times, and today I'm going to discuss our team's journey over the last couple of years with network automation, and more specifically how we've learned from our cloud and platform teams at the Times and how we've been able to apply some of their strategies towards our classic enterprise network. Our mission on the network team is connectivity, so we deal with campus wired and Wi-Fi network, firewalls and their rule sets, the global offices, our printing plant, which gets the paper out every night, the data center, production data center, as well as cloud routing between on-prem and our cloud providers, as well as our VPN, our corporate VPN solution. This is probably similar to what many network engineers in mid-sized enterprises do as well. And for us, we found that trying to apply network automation made our life a little bit easier. Now, when I'm talking about platform engineering, a good chunk of that is automation, right? But that's not the only thing, right? So in my opinion, a day zero task for most network teams should be to learn Ansible and Python. Now, if you're not there yet, that's okay. A conference like this is a great place to start, right? I mean, Kirk Byers, I think I've taken every one of his classes. So start there and learn those skill sets. But then the question is, what's step 2 and what's step 3? In my opinion, the next evolution of that is taking those automation tasks and wrapping them around source control, infrastructure as code, centralizing them, and creating self-service wherever possible. Now, in our specific case at the Times, our cloud and delivery engineering teams, they are very mature and they have advanced CI/CD pipelines that deploy to prod, and they do a great job. Now, on the infrastructure side, we're not there yet. We're working on it, but there is a gap. Now, why does that gap exist? Is it because network engineers don't want to learn something new? No, I mean, I don't think that's the reason. I think the reason, partly the reason is when working in cloud environments, it's a homogeneous environment. It lends itself to programming, easier to program, and it's a consistent environment. Now, with on-prem, it's not so consistent. We don't have those traits, so we kind of have to create our own consistency. And there are some challenges in doing that. So what are some of the challenges? Vendor sprawl is a problem. So with us, we go with best of breed. We don't lock into one vendor. But the flip side of that is if you solve a problem one way, well, now you might have to solve it 2 or 3 times again, and that creates complexity. The layer 0 problem, before you even get into the infrastructure and network, you might not have 2 sites that are the same. There could be circuit availability problems or regional regulations where you can't get the same equipment in site A and site B. So you have to account for that, again, before even talking about infrastructure and network. And then there's this human factor, right? So there's hidden work. If you have a network engineer who's been doing it for 20, 30 years, they might have institutional knowledge where they only know how to solve this problem. Now, how are you going to build a automation workflow around that, right? So that's a challenge. And fear is a challenge, I believe, for all engineers, no matter what your seniority level is. When you build complex networks, there will be unknowns. And especially in talking about automation, you don't want to fail at scale. And entropy is a problem. Unexpected state changes will happen. So if you have your desired state and then your running state out there, what's in the network, stuff will occur, whether that's your team causing those changes or stuff that you can't control. Well, you have to account for that. So how do we start solving some of these problems? So as I mentioned before, let's say you get 1 or 2 or 3 network engineers who now know how to write some Python jobs or create Ansible playbooks Well, you don't want to just have them run on some random cron job somewhere or a hidden server somewhere or on somebody's laptop. You want to condense your execution paths of how your automations are touching the network. You want to limit them as much as possible. So specifically, for example, for Ansible jobs with us, we'll use AAP or Ansible Tower, and that will give us the ability to have access control, centralized execution, gives us visibility, and it's repeatable. Now, for more complex tasks that maybe require some Python logic behind it, well, okay, let's see. What are our platforms team doing? Well, they've already have GitHub Enterprise, drone CI pipelines running, Terraform, and HashiCorp Vault for secrets. Well, how can we leverage those existing tools that already exist in the company for us on the networks team? So, all right, so let's say a network engineer comes up to me and says, well, I wrote this Python job that logs into our VPN server and provides this information to this team that asked for it. That's great. That's great that we did that. But let's take the next step or 2 weeks and let's wrap that job around a system, meaning let's put it in GitHub, and maybe if this is a scheduled job, we can put it in a Lambda. So you write a Terraform block of code that deploys this Lambda, deploy it with drone, and if that changes in the future, or in a year that changes, or somebody else wants to make an edit to it, it's all there, it's all visible. Or even better, you can provide the ability for whatever team is asking for this information from the network team to maybe run the drone job themselves, or to commit a PR against that repo to make changes as well. So that's kind of the takeaway I want to take from that is take your automation task and think about what the next step is in putting them in platforms. Just an example of kind of what I was talking about. On the right there, we have the Ansible Tower. So if you have a playbook, you want to version control it in GitHub, and then easily visible, right? You have jobs, you have your schedules, and same thing on the left with drone pipelines, similar concept. You want to avoid overhearing, oh, it only runs on my machine, or I didn't know this job exists, right? So that's the concept for that. Now, in that same theme of minimizing your runtime environments, you also want to condense your data paths, right? So if we think of the network as all these autonomous databases all around the world, hosting their own version of their state, you want to try to condense as much of that as possible into a single relational database. In our case, we went with NetBox, and it's not going to be the single source of truth, in my opinion. You get it as close as possible to be functional enough where now you can drive your automations. So get as much data as you can that's accurate in your source of truth. And then for us, in our case, so all right, so now we have some supporting systems for observability. For example, synthetic testing or monitoring or our log aggregators. Well, let's feed all of that data from our source of truth, not the other way around. Don't log into your monitoring systems, and do an export of, okay, this is the devices I have in the field. It should be reversed, right? Similarly, it can drive your operations. So if your network engineers need to maybe upgrade a bunch of routers or switches running an older version of code, they should pull that information from your source of truth. Everyone should work from the same set of information. And more importantly, it should be used for configuration management as well. So that bumpy vendor landscape I was talking about earlier, well, we can flatten that out a little bit by being able to provide common services and deploying them universally. So how do we do that? So here's an example of a golden config template. So we take a Jinja 2 template, it's in GitHub, and you can apply conditional logic based on what type of device you're talking about, right? So maybe this router, this switch is a NAC, needs some NAC config on it, so you have a conditional statement in there. As well as you can, from your source of truth, use config context to dynamically populate information, meaning if you have a router in Europe versus a switch in Asia Pac, it might need different content in there compared, but you can still use the same template, so you can dynamically load that. As well as secrets, right? So if you centralize your secrets and dynamically load them, you can easily rotate your secrets. And this concept kind of marries the two things I was just talking about, which if you centralize your data, and condense your execution paths, now you can deploy these type of configs universally. And with Ansible, you can also do commit check for most vendors, where you can do a compliance check across your network and see, okay, well, I ran this across my network. I didn't make any changes, but I see maybe 6 devices are out of compliance, and now I can rerun that in enforcing mode and fix those devices. And so the idea is you don't want to see somebody say, oh, I installed this new site and I forgot to enable this service, or I forgot to disable this service. So this is one way to prevent that. Or somebody saying, oh, let me pull up that base config I have, version 7 on my laptop. That's what we should be using. Like, no, you want to try to centralize that. And just continuing on that logic. So we use tagging to dynamically drive our automation tooling. For example, if something needs to be scanned by InfoSec scanners, we'll tag that. Or if it needs to be in a monitoring system, we'll tag that. As well as we'll tag prefixes. So if the DNS team, for example, needs to know a list of, what IPs are coming out of this site in France, well, we can provide that. And we can provide API access into the system, or we can also give other means of visibility. So maybe more commonly asked questions, we can create // commands, which anybody can run and grab that info. Again, limiting the amount of work or tickets that maybe come into network engineering, and using that time elsewhere. So the other solution I want to talk about is this idea of a staging environment. Now, in the programming world, that's common, right? The idea of an alpha, beta, or staging environment is common. In the infrastructure world, it's not so common, right? If you're lucky enough to have one-to-one hardware replications, that's great. I don't know many teams that have that. And other options like VM-based modeling of the network can work, but it's a little clunky to get working. It's not really scalable and repeatable, and they're also resource intensive, right? So one router might be 32 gigabytes of RAM, and if you have to deploy a 10 router model, now you're talking about a pretty beefy server that you need. And luckily, there's a new tool that is out recently, Container Lab, which lets you deploy containerized versions of a network operating system if the vendor provides it, and then you can model sections of your network. Now, for us specifically, we don't model our whole network because it's too complex, but we can pick and choose. So if we have a refresh project coming up, or if we want to test out something in one part of our network, we can load it in Container Lab and run our tests. Now, why is that important? Because so configuration compliance is great, but you don't know necessarily how your config is going to affect the behavior, how it's going to affect the behavior of the network. So the beauty about Container Lab, not only in one YAML file can you spin up your model, you can also stick Linux containers at the end of each of those routers, and you can run iPerf testing, HTTP testing, and more importantly, you could do Wireshark captures right on the line there, and you can see your packets. Us specifically, we had a scenario where we had a build out in our storage network, a new build out for our SAN, and we made a purchase of some Arista gear. And while we were waiting for that equipment, supply chain and all that stuff, we spun up the COS in Container Lab. We modeled it, built a configuration deployment around that, and it was ready to go in staging. And then when the gear came, we racked and stacked it, changed one flag in the pipeline, and then deployed it to prod. And now, if we have to make a change in the future, you could deploy it to stage, validate and test, and then deploy it to prod. That also helps the idea of fear, as I was talking about earlier. So if you have a new engineer or a new hire who maybe doesn't know part of your network, well, how can you automate that? Well, if you have a YAML file that can spin up an entire piece of your network, that's easy enough to share and duplicate, and then they could learn that, and then you go from there. All right. The last thing I want to talk about is the idea of operational feedback loops. So when running a brownfield enterprise environment, and you pick and choose what automations you want to work on or what part of the network you want to automate, there's going to be times where your desired state versus your running state is out of sync. So our best solution for that is just to constantly write jobs that go out and grab the accurate data and reset our source of truth. Some examples of that might be maybe you upgrade your switches, your versions, or you swap out devices, and the model number changes or the version changes, and you want to update the source truth because maybe the engineer forgot to update that. Well, this is one use case for that. Another use case may be out of your control. If you have a remote site in a part of the world that maybe doesn't have a great internet connection, or maybe it provides a satellite connection that the IP address changes often, again, you can go out there, grab your information, and sync up your source of truth so that on the next time you run your automation or report, you have fairly accurate data. Just some quick examples. If your MAC address changes or your serial number changes, you can go out there and grab the data, and for the most part, it's going to be accurate. Another quick example would be if you're syncing a firewall object to maybe a publicly available prefix list like a Google or Amazon prefix list or Fastly prefix list, and the provider makes a change, that shouldn't affect your workflow, right? It shouldn't break your workflow. So if you're constantly syncing those together, you should be good to go. So to recap, platform engineering is great, but it's hard to do on-prem. There are some challenges, including vendor sprawl, the layer 0 problem, hidden work, fear and entropy, and some solutions, creating operational feedback loops, condensing your runtime and data paths as much as possible, and where possible, deploying digital twins to model your network. That's it for me, and I'll take any questions if there are any. How did I do on time? Yeah.
Great talk. How about container labs? What kind of how big of your network you used on the container lab environment?
Just bits and pieces that we choose. Like I gave that example with the storage network. So that wasn't a very large deployment. It was I don't remember the exact number of nodes, but it was I want to say 6 nodes, and then obviously we containerized some of the Linux servers around that to test it. But we'll pick and choose, and we have a refresh coming up for part of our WAN network. So we'll put that in there. So yeah, so it's kind of.
So you only look at the control plane.
I'm sorry, say it again.
Only looking at the control plane part. Right?
All and the routing too, and you could also contain you can test out like MLAG. You can test out. So yeah, you can get a decent approximation.
Between Container Lab and other tools like GNS3, even NG, were you be able to compare those?
So I've used GNS3 before. I think the benefit with Container Lab is everything is in a YAML file, so it's easy to spin up, tear down, change the links. So I think it's good in that respect. The one negative is not all vendors support containerized operating systems yet. Nokia, Arista has some. I think Juniper has a little bit, but so that is the one drawback right now.
Thank you.
Yep, no problem.
Hey, thanks for the great presentation. Chris Cummings, Energy Sciences Network. I wanted to ask a little bit more about your digital twinning points there, because that's obviously a pretty big one. How are you handling pulling in production config and populating your digital twin to match an ever-changing production environment? Or are you just trying to model a representation of production?
Yeah, it's easier to do, obviously, in a greenfield deployment, at least for parts of your network, right? Because then you can kind of control the process a lot more, and you can say, let's not make any changes to our network unless you go through this process. It is harder to do in existing environments, so we're still working on it. It's a kind of a work in progress, but yeah, it's not an easy answer. You are right about that. Yeah.
Cool, thank you.
Yep. Hey.
Hi, Chris Woodfield. So there is a saying, every network has a lab environment. If you're lucky, you get a separate production environment.
Right.
So back to the container lab example. Have you run into any issues where you discover that the feature parity between the containerized version of a network OS and the hardware version isn't one-to-one? Have you I've run into that occasionally in the past, particularly with layer two encapsulation functions and layer 2 bridging functions. I don't know if you've.
Yeah, I'd say definitely. Even in the config, actually, I believe in the Arista container, I think they call the management interface something different than the real switch. So I had to put a conditional logic in there to change that in the pipeline. But yes, I mean, I have run into that. It's a close approximation, but you're right. That is a challenge that you will run into for sure.
Okay. Vendors, are you listening? Thanks.
Hey, there we go.
JB.
Hey, Kaon, thanks. Great talk. Great contribution to the community, as always. You'd mentioned about Netbox not being the full picture, and I guess there's gaps, or you said kind of ish.
Yeah.
Can you kind of elaborate the gaps and then what you're using to fulfill?
Yeah, of course. Yeah, I mean, in a brownfield environment, right? You're not going to run everything. Everything's not going to be out of Netbox, and that's expected to be the end-all declarative state of the network. Because in reality, you CLI into the router, and that's your end state. Like, that's the way packets are routing. I don't care what some other system says. So you have to accommodate as much as possible. And the feedback loop is one way to accommodate that. Obviously, changing human culture as much as possible, making sure people update the source of truth, running those checks, whether devices are supposed to be where they're supposed to be and supporting systems or not. So it's a process. Yeah.
Cool. Thank you.
Yep. Hi.
Just curious where you are as far as your journey now when you're looking to bring in new equipment and you're doing a POC of a number of vendors. You're now at the stage where you've got enough buy-in from management and everyone else. It's like, it will either work with our stuff or it's in the bin. I don't care if it's the cheapest device. Like, where are you at with that?
Yeah, I mean, that's at least, if anybody, does ask my opinion, that is one major point I have, is it has to be automation friendly. So yeah, it has to have a REST API or updated Ansible libraries, or so yeah, that is, at least in my opinion, a big feature, that the vendors should be automation friendly, for sure. And there are vendors out there who are not. I mean, I'm not going to start shaming them, but yes, or their API doesn't work, or it's got bugs in it, right? So but that happens. Hey.
Hi, Lou. Somebody who's done some brownfield automation work to some degree with Netbox and all that, how much time did you have to spend on development for your stuff that was already brownfield, and how did you solve your feedback loops to make sure that your source of truth was consistent?
It's a constant. It's like you're always solving, right? But I'd rather, what's the word? I'd rather spend cycles, making sure that we're in sync versus the opposite, which is not doing anything, right? Or just continuing the way it is. But as far as time, I mean, this has been a multi-year process, right? And as far as the grand scheme of things, we're still doing a ton of manual CLI work, but we pick and choose where we can get those easy wins. We first started read-only, right? Getting backups, and then started making changes where possible. But it's a journey, as I'm sure other people will say here as well.
Thank you for sharing.
Yeah, sure. Hi.
Can you talk a little bit about if you push something, everything looks fine in Container Labs, you push it to production, it breaks, how you reconcile that process?
Yes. Well, then you got to get your hands in the CLI and start working it. I mean, well, specifically, the one benefit, I know I talked specifically about the Arista configuration there, but with CVP, you can reconcile config. So even if your running config is different than what's in your template, you can reconcile that through the platform, or you can just manually do it. But yeah, that will require some manual work. And you just have to keep iterating on the process. That's the whole idea, I think, of these DevOps principles and what we've all been talking about is iterating. But I do believe it's more valuable to focus your energies on maybe fixing those processes and iterating on that than just keep doing what you're doing, which is, okay, I'm going to make this change on the CLI, be done with it, close my laptop, and be done. Yeah. I think there's more value in doing it this way.
Gotcha. Second part of the question, sorry. Is there a process or things you've chosen to collect for metrics to compare? So the live state of the network versus the modeled state, if you will?
Well, so right now they are the jobs are kind of batch jobs where we go out and pull the data. But I think somebody at some point, maybe it was Scott, mentioned to me, have you ever thought about maybe having your devices sending the hook out to update the source of truth when they have a change? So that's actually an interesting thought that I want to look into. But right now, yeah, we're going out and pulling the data and reconciling it with logic and with code. But maybe the next step is having the devices push out those changes and letting you know about it.
Yep. Thank you.
Yep. How you doing?
Hey, good. So kind of along the same lines of the feedback loops, how often are you guys like running those jobs, right? Because the last thing you want to happen is to be relying on your source of intent, push something out that conflicts with your running state. So how do you reconcile that?
Yeah, it depends. Some jobs will be daily. Sometimes, more than that. But yeah, I mean, basically, they're just batch jobs. We'll go out and check the network, and then we'll update the source truth. But yeah, as far as frequency, daily, I do think we might have some that are more than that. I have to think about it, but definitely at least daily. And in the end, your change, you should still peer review it, and you should still reconcile it with your own eyes. But if your change is scripted out for you, with, like I said before, with the commit check feature in Ansible, right? So if your expected change is this, you're like, wait a minute, that doesn't look right. There should still be manual intervention there at some point, because we're not a fully automated, fully autonomous network by any means, but it'll just make your life easier and prevent errors and mistakes if you can see that before pushing out.
Gotcha. Thank you.
Hey, how you doing?
Hi. So I've got a question about the tooling you're using. You mentioned...
I'm sorry, can you give your name real quick?
Martin.
Okay.
So,
Hi, Martin.
and you mentioned the tooling you're using, and you mentioned Ansible and Ansible Tower. Are these the only tools you use for doing the configuration changes on network devices, or?
It's a big chunk of it, because Ansible does lend itself to configuration management, but then we also have Python jobs that, for more advanced stuff, that maybe some vendors, they have an API for, but their Ansible libraries aren't as mature. So then we'll just create Python jobs that just go out and do stuff. So like, whether I sync maybe our InfoSec scanners with their platform to our platform, stuff like that needs Python access, yeah.
And the configuration changes are done on CLI basis, so textual configuration changes, or are you also make use of Yang models in some cases?
I'm sorry, what was the last part?
The Yang models, so some vendors...
No, right now we're doing Jinja 2 templates with dynamically loading the config context through Netbox. So if a device is either tagged with some conditional logic, or if it's in, for example, in a site that I know is, for example, EMEA or APAC, then I know these devices will get this part of config based on weighting. So for example, the DNS servers, if you're a switch in Asia-Pac, you're not going to resolve to the DNS servers in Europe, so you'll wait to Asia-Pac. So we're doing it through Jinja 2 templates and through config context through Netbox.
Okay, thanks.
Yeah, no problem. Hey.
Hi, Max Turpin. How often do you find your network drifting out of compliance?
So it depends. I mean, it happens, but it could be because, for example, so we'll make a change. So for example, maybe a switch has a service that we know should be disabled, but maybe somebody enables it for some troubleshooting and they just forget to disable it. I mean, like maybe allow root access or something like that, right? So it happens, and then maybe once a week or a couple times a month we'll get the report back that says, oh, these devices are out of compliance. And it's an easier fix because now you see exactly what's out of compliance and how to fix it, and you just rerun that job in enforcement mode and fix it, or you you figure out why is this out of compliance. Maybe this is a reason we have to now change our Jinja 2 template to be, no, this is the new golden config. Now we actually, there's a reason why we did this, because we solved some P1, and now we have to deploy this everywhere. So it happens, and it's just a constant evolution, sure.
So you don't lock your engineers out of the CLI?
No. I mean, I wouldn't be up here. They would have, people would be at me with pitchforks if I said no more CLI. This is a staged approach.
Thank you.
Yeah. Oh, I'm sorry. Oh, all right. Well, that's my time. Thank you.